What is going on, guys? My name is Brent and welcome to part 12 of my tutorial series on how to create the game Super Mario Brothers. So in this tutorial, we're going to learn about how to identify what objects Mario is colliding with, which will eventually lead us into manipulating those objects, like destroying bricks and adding points to our HUD when we hit coins and changing visual effects of tiles. So if you're interested in that, go ahead and stick with me. So the first thing I want you to do is go ahead and go to your play screen. At the bottom of the constructor, we are going to say world.setContactListener. We're going to set that to a new world contact listener. And we haven't created that yet, so it's going to be red. So let's go ahead and do that now. So inside of our tools package, we're going to create a new Java class called world contact listener. And this is going to implements contact listener from bad logic, and then what we're going to want to do is generate all the methods. So there's 4 methods here: begin contact, end contact, pre-solve, and post-solve. Now let's talk about what a contact listener is. A contact listener is what gets called when 2 fixtures in box 2D collide with each other. The first 2 are relatively simple: begin contact and end contact, and those are the main ones we're going to be using. Begin contact gets called when 2 fixtures begin to make a connection or begin to collide. End contact is when those 2 fixtures disconnect from each other. So those are relatively simple. Pre-solve gives us the opportunity to, once something has collided, you can change the characteristics of that collision, for any given reason. And post-solve gives the results of what happened due to that collision, like what angles the fixtures went off at and stuff like that. We're really not going to be talking about pre-solve and post-solve. Some more information regarding those methods can be found on the Box 2D documents. So if you're interested, go and check those out. So really quick, I've added 2 logs, one in the begin contact and one in the end contact, just to demonstrate really quick. When Mario jumps up, you see an end contact because he stopped colliding with the ground, and when he hit the ground again, you start another begin contact. Now, what we're really interested in for this tutorial is when Mario collides with an object on his head. So if he's jumping up and he hits a brick with his head, we want to know about that collision. So we need to go to our Mario sprite here, and we need to, inside the define Mario function, we need to create a sensor on Mario's head. So to do that, we're going to create a new edge shape called head. And we're going to say that's equal to new edge shape. So an edge shape is basically just a line between 2 different points. So to define that line, we need to say head.set, and we give it 2 vector 2 quantities, so 2 x and y coordinates. So the first one, new vector 2, will be -2. Divided by Mario Bros.ppm. We're just going to copy, or we'll do this in a sec. And then 5 divided by Mario. And this is all in relation to the body's origin, or the center of the body, divided by Mario.ppm. So let's go ahead and copy this quantity. And then that's the first coordinate. So it's going to be offset to the Mario's left a little bit by -2 and 5 above the origin. So above his head, basically. And so the next one will be new vector 2 quantity. But this time it'll be +2. So it's in front of him a little bit, but still at the same height. So now what we're going to say is the f definition dot shape equals head, and then we'll set our b2 body dot create fixture to the f def, and we'll say get set user data, and this will uniquely identify this head fixture as head. So we can pull this in the future to see if this fixture is actually Mario's head. One other thing I want to add is fdef.isSensor equals true. When you create a fixture definition that is a sensor, it no longer collides with anything in the world. It is just available for you to query to see if it has some user data or something like that. So it doesn't collide with anything in our Box 2D world. I had to adjust the head to, instead of 5 to 7 divided by ppm for the y-axis. But looking at it now, you can see that Mario has basically a little hat above his head. And I've adjusted it to 7 so you can actually see it. But for now, we're actually going to put it down to 6, so it's basically level with his head, and it's a little bit harder to see. But at 7, you can see it. So inside of our interactive tile layer, when we create the fixture that surrounds the tile, the brick, or the coin, what we're going to do is capture that in a variable called fixture. And up above, we'll define it, protected fixture. And then in each of the objects here, the brick and coin, will say fixture dot set user data to this. So we're setting the user data to the object itself. Same with coin. Fixture dot set user data to the object itself, so we have access to this specific object. Now what we're going to do is, inside the interactive tile layer, we are going to create an abstract function called onHeadHit. So public abstract void onHeadHit, and then, or actually we don't even need to do this on an abstract function. So we'll just define these variables here. So we'll generate those methods onHeadHit, and then same with the coin. We'll generate the method onHeadHit, and there we go. So for now, we're just going to log something, gdx app.log, and we'll say coin, and then collision. For this one, we'll copy it, and we'll do the same for brick. Rename this one. There we go. So let's go to our world contact listener, and we're going to get rid of the log here. Now, a contact in our begin contact has two fixtures, a fixture A and a fixture B. They're the two fixtures that are in the process of beginning contact. Now, we have to figure out which is which because we don't know originally. So first off, let's get them. So we have fixture, and we'll call it fix A equals, let's bring that in, contact dot get fixture A, and then we'll get fixture fix B equals contact dot get fixture B. Next off, we want to test if either one of these fixtures are Mario's head. So to do that, we say if fix A dot get user data equals head, or fix B dot get user data equals head, then we know that the collision has occurred with Mario's head. So let's create two more fixtures. Fixture, and we'll call this one head. And this one we're gonna see if fixture A dot get user data equals head. And then we want fixture A. Otherwise, oops, this is supposed to be a question mark. Otherwise, we want fixture B. And then we're going to say fixture object equals, does head equal fix A? If it does, then we know that fixture B is the object. So fixture B. Otherwise, we know fixture A is the object. So now we have two fixtures and we know what each one is. One is Mario's head and one is an object, but we don't necessarily know that that object is an interactive tile object. Maybe it's the ground, maybe it's a pipe, whatever. So first off, we need to say if object.getUserData does not equal null, and we want to see if the object getUserData is a extension of the interactive tile object. So this is a coin, but it extends interactive tile object. In order to test that, we have to use a mouthful of methods here. We're going to say interactive tile object dot class dot is assignable from, okay? And then we'll say the object dot get user data dot get class. So this will return true if the object's get user data is a interactive tile object class. So it extends that. So now that we know that our object is an interactive tile object, what we can say is interactive tile object object dot get user data, and then we'll surround these in parentheses, and then we'll say on head hit, so we can execute that method. So let's go ahead and get rid of the end contact log here as well, and I want to go over this one more time. First off, we have two fixtures. We don't know which either one of them are. So we're going to test to see if one of them is the head first, Mario's head. So if it is, then we want to get the head and the object that it collides with. So we create two new fixtures and get the head by testing whether or not each fixture has the user data of head. And then the object is the other one other than the head. So then what we do is we test the object to see, first off, if its user data is null. And if it isn't, then we need to test to see if the user data is an interactive tile tile object. If it is, then we know each interactive tile object has a method on head hit. And so since the head has hit a interactive tile object, we should go ahead and execute that method. So I've gone ahead and run the game, and I've removed the graphic from the B2 body for now so you can see what's going on. But you can still see now that the sensor of Mario's head is right at the top of the circle here. And you can see the log right below here. When we come in contact with a coin, we get the coin collision log. When we come in contact with a brick, we get the brick collision. And then when we come in contact with both, basically we get a brick and a coin collision at the same time. So that's pretty much it for this video. I hope you guys learned something. Another lengthy one, but I hope it was put to good use. We talked about the world collision listener that listens for two box 2D bodies to collide. And now that they've collided, we can identify them and execute certain methods depending on what objects collided, like a head and a brick or a head and a coin. And so we're going to use this in future tutorials to add scores to our HUD when we hit coins, and add or destroy bricks when our head collides with the brick. So if you're interested, go ahead and keep following. If you like this video, go ahead and hit the like and subscribe button. I greatly appreciate it. But most importantly, please share it if you do like it. If you want to feel generous, check out my Patreon page. I give you 2 big thumbs up for that. I appreciate everybody watching, and I'll catch you guys next time.